Good morning, everybody. Welcome to a fall morning of Chem 1105 with your host, me, Dr. White. All right, here's what we're going to be doing today. First, I'd like to finish up a little on the acid base for titrations. Next, based on some of the labs I graded and I've uploaded this morning, more lab scores, some of you need help with calculations. So I'm going to go through some important calculations that will help you immensely on Friday, because on Friday, I'll be giving test number 3. So that will help. And then after that, we'll go through today's lab, which is on Beyond Lab Z, and it's a lot of fun. Hold on 1 second. My glasses are dirty. Oh, now they're okay. By the way, if you get these inexpensive microfiber towels from Walmart, and I don't get any kickbacks from Walmart, they're great for cleaning glasses. All right, so that's today's game plan. And like I said, if you get cut off, don't worry about it. Just email me that happened, and I'll make sure I adjust my attendance records properly. All right, let's get going. What I'd like to do first is talk about titrations. And yesterday, I talked about titrations are when you have a neutralization reaction, which a measured volume of acid or base of known concentration is completely reacted with a measured volume of acid or base of unknown concentration. And what a titration allows you to do is calculate the unknown amount of acid or base, which allows you to find out the molarity of that unknown acid or base solution. So that's the key for titrations. You use an indicator, which we'll be using today, and that changes color at a certain pH, and I'll usually call it a pH indicator. I don't know, I guess there are other types of indicators. The most common is phenolphthalein, and that changes color below pH 7. It's clear. One molecule of base above pH 7, it turns a red or wine red color. My sisters always tell me, you don't know your colors. I know red, green, and blue. They still laugh and say you don't know your colors. Good. And at neutral pH, you know the molarity, moles of known acid or base, and you can use that to calculate the molarity of the unknown. So let's look out how to do that, because you're going to need this skill for today's lab. Let me give myself a little more room here. And remember, this is for test number 4 material, but it will be for today's lab. By the way, does everybody see me writing on the whiteboard? I'm going to check my thumbs up, people. Thank you. Thank you, Ruben. You were the first. All right. one thing I should point out, I've been trying, habits are hard to break. This is equal to, 3 lines means exact, to C and then an L. So anyways, this is HCl. All right, now let's go through this. It takes 151 milliliters of a 1.21 capital M NaOH solution to neutralize, and that's the key. Or I might also write to change the color of phenolphthalein indicator, which means to neutralize 245 milliliters of an HCl solution. Then what is the molarity of the HCl solution? So what are we being asked to find? Molarity of HCl. Remember, M means molarity. Hopefully you'll learn that for Friday, because you'll need that knowledge. We're given 151 milliliters of 1.21 molar NaOH solution. You're also given 245 milliliters of the HCl solution. And I didn't open it up, so I better do it now. This is from test number 4, important information. Remember, what I'm going through now will not be on test 3, will be on test 4. At neutralization for titrations, moles of acid equals moles of base, which for a monoprotic acid or base, you can use the formula mils of acid times molarity equal mils of base times molarity of base. So for the problem we're doing, we can immediately say moles of acid equal moles of base, and for this class, milliliters of acid times molarity of acid equals milliliters of base times molarity of base. And before test number 4, which is coming up in a couple of weeks, you should know NaOH is a base and HCl is an acid. And what we're trying to find here is the molarity of the acid. Now, I'm going to put in the numbers. The milliliters of HCl is 245 milliliters HCl. That's what this is. The molarity, we don't know. The milliliters of the base is this right here, 151 milliliters. The molarity of the base, and this is one of the rare times you don't have to say, what does that mean? And write in moles per liter, because I've simplified this. And that is 1.21 molar NaOH. Now, so I can share the fun, I'm going to ask you, this is what you're trying to solve for. Why don't you try right here? Help me out. Do a winky dink. I've talked about winky dink in the past. And why don't you solve for molarity of acid, which I should have written in HCl. Solve that equation. Don't do the math. Just set it up. Your turn. Then I'll do it. And when you're done, give me a thumbs up, or maybe I'll do the poll. I'd like to thank, who is it, Nick, who let me know about Comcast being out, because probably that's why a lot of people are not here right now. At least I hope it is. Or did somebody send out a fake email that's this is National Cut Class from Dr. White Day? I'm glad to hear some of you are logging back in. I used to, last semester, I had problems with my modem router. And then I realized, wow, this thing is too old and it's time to replace it. And I got a nice Nighthawk and I haven't had any problems. I better be quiet. Don't say any more. All right, let's assume everybody's done. And it's my turn to help you out. All right, what are we solving for? Molarity of HCl. Well, if I want it on one side, I have to get rid of this. And how do you get rid of something that's multiplied times something you want to keep? You divide by it, because anything divided by itself equals the number 1. Remember, A divided by A equals 1, meaning this cancels out. Well, whatever you do to one side, you have to do to the other. And I will. This cancels out. I'm now left with molarity HCl, which we're trying to find, equals and if we look at just the units, notice I have molarity, not molarity, milliliters here, milliliters there. That cancels out. I'm left with molarity, which this is molarity, which means I'm on the right path. And now I'm going to pick up my calculator. First of all, turn it on, clear it. And my calculator gives me the following answer. I love calculators. And on test 4, like it will be on test 3, please use proper significant figures for all calculated answers. I'll let you figure out what would be the right answer using significant figures, and then I'll do it. I'll give you 10 seconds. go. I'm looking at my clock now. Time's up. This is 3 significant figures. 3 significant figures. Oh, he's in his rut again. 3 significant figures. Therefore, round this off to 3 significant figures, because your answer for multiplication division should have the same number of significant figures as the number with the lowest significant figures, which is 3. Keep the 7, keep the 4, keep the 5. That's my 3 significant figures. Use the 7 to round off. That's 5 or higher. I'll drop all this, increase this by 1. So the correct answer is the molarity is 7.46 times 10 to the minus 1 molar, and we're getting HCl. And that's how you do titrations. Now, after test number 3, I'll come back. We'll do more of these, but I wanted to cover this for today's test. Not today's test. What am I saying? Today's lab. Got test on the brain. Uh-oh. But anyways, that's what we'll do. Now, what I'd like to do is first drink some tea. Oh, I love blueberry tea in the morning. That's from the Republic of Tea. Well, I'm going to go through now some important calculations because some of you need help. Come back and watch this video, which I'll post later today or late this afternoon at the latest. I hope I got a lot to do after lab today, but I should have time to get that done before early evening. So let's go through some important things you should remember how to do for test number 3. Tomorrow, I'll still do my review. So first thing I'd like to review is how many moles water is 27.6 grams. So what are we being asked to find? Moles water. What are we given? And before I proceed, I better open up something I didn't. Thumbs up, people. Do you see important information on your screen? Uh-oh. I see you do. Let me check, double check. All right, now you should. All right, now this is for test number 3, Friday. Thank you, everybody. And it says 1 mole of a compound, in case you forget. Remember, I've really cut down on important things you have to memorize. 1 mole of a compound equals the molecular weight of that compound, and the molecular weight of that compound is the sum of all atomic weights. So what do I have to start with? This. What am I trying to get to? This. And what time is it? You're right. It's time to use your good buddy, your good friend, unit analysis. And it is. And how do you use it? Do you have a ratio that you can go from here to here? What's on that ratio? Using your good buddy, your good friend, unit analysis, whatever you're trying to get to, the units go on top of the ratio. Whatever you're trying to get rid of, the units go underneath. And I'll put that in there. And where do we get this? 1 mole equals the molecular weight in grams of a compound. And the molecular weight of a compound is the sum of all atomic weights. And therefore, water, which we've done before, but I'll do real quick, 2 hydrogen, 1 oxygen. The atomic weight of hydrogen to 3 significant figures is this. For oxygen, the 3 significant figures. Remember, the number underneath the symbol in the periodic table is atomic weight. And on test 3, it will say under your name, please use proper significant figures for all atomic weights. Add these up. When you add, you have the same number of significant figures to the right of the decimal point as the number that has the fewest significant figures to the right of the decimal. This has 2, this has 1. What's the smallest number? Hopefully you pick 1, keep the 0, drop the 2 because it's 4 or less, and this is 18.03. This is an exact, let's try this again. This is an exact number. This is 3 significant figures. My answer should have 3. If you notice, grams of water divided by grams of water, which comes to number 1. So now I can turn on my calculator, clear it, take 27.6 divided by 18.0, hit enter, and I get, I love my calculator, 1.53333, some more 3s, times 10 to 0. Round this off to 3 significant figures, 1, 2, 3. Oh no, this never happened before. Use 3 to round off, and that's 4 or less. I drop this, so it's 1.53 times 10 0 power moles H2O. Remember, 10 to the 0 is 1, so you could write it that way, or you could just write it this way. Either one would be correct. Now, let's you try one. Let's do this stepwise. First, right here, write what are you being asked to give, get, or find, what are you being asked to find, and what are you given? I'll give you 25 seconds to figure that out. Go. All right, I think that was 25 seconds. You're being asked to find grams of HCl, and you're given 5.666 moles of HCl. Remember, 1 mole of a compound equals its molecular weight. You fill in the rest of this with the units. I will tell you this, the molecular weight, and of numbers too, of HCl, hydrogen, there's 1 of them, 1.01, chlorine, 35.5, And this adds up to 36.51, and I'll do and help you out. So this is a molecular weight of hydrochloric acid. So why don't you figure out what goes here, units, and what units go here and here, and also what numbers go here. Your turn. I keep on saying I should get some game show music because you really don't want to hear me hum or sing. No, even I don't want to hear that. I put on headphones when I sing. I was just thinking, I'm glad for those, well, not glad, but I'm relieved that it happened today and hopefully not Friday, the outage. If that were to happen, I'd give extra time if somebody lets me know that's what happened to them. All right, I think everybody's done, so let's do this. What are we trying to get to units wise? Grams of HCl. So now you use your good buddy, your good friend, unit analysis. I don't want you to have siren overload or overdose, so I won't use it again. And whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. Remember, show your work Friday. It helps you get a better score. Grams go on top, HCl, moles, HCl go underneath. And this is 36.5. This is 1, 4 significant figures, exact number. Oh, 3 significant figures. How many significant figures should your answer have? Well, what's the lowest significant figure of that in a multiplication division? And the answer is 3. So our answer should have 3 significant figures. Notice moles of HCl divided by moles of HCl cancel out, and I'm left with the right units. Clear my calculator. And my calculator gives me this number. And don't forget the little 0 or numbers after the tiny little 10, because that's the power of 10 right here. And this should be 3 significant figures. So I keep the 2, keep the 0, keep the 6, use the 8 to round off, drop that, increase this by 1 because 8 is 5 or higher. And that's how you do it. And these are 2 skills you should know and go back and practice for test number 3. Now, what I like to do is go through from the practice problems to remind you how to do something. And if we look at number 3, and let me make sure. All right, everybody see how many atmospheres is 741 torr on your screen? Nobody? Thank you, Nicholas. I got to train you people to do more thumbs up for me. All right, now, what are we being asked to find? ATM, atmospheres, that's a pressure. We're given 741 torr. And on test number 3, important information, it will have 1 atmosphere equals 760 torr equals 760 millimeters of mercury. So we start here. We're trying to get the atmospheres. If you have a ratio, use your good buddy, your good friend, unit analysis, atmospheres goes on top, torr goes underneath. Notice that this is 1 atmosphere, here 760 torr. These are both exact numbers. This is 3 significant figures. Our answer is 3 significant. Now in the next one, 4, how many torr is 1.237 atmospheres? We're trying to find torr. We're given atmospheres. You can't, now you can see it. We're going to torr. Torr goes on top of the ratio. Atmospheres go underneath. Again, right here, and this will be given to you important information. Test 3, we have 1 atmosphere equals 760 torr. These are exact numbers. Notice this is 4 significant figures. 760 and 1 are exact. Therefore, the only number that plays a role in how many significant figures my answer should be is this 4, and therefore my answer is 4. Oh, I got out of my rut. Yay. All right, next, let's look at number 6. You should know how to do one of these. If a balloon has a pressure of 658 torr and a volume of 1.894 liters, what is the pressure of the balloon if the volume is increased to 5.133 liters? Now, what are we being asked to find? A final pressure after you make a change, which I'll call P2. What are you given? The initial pressure, P1, the initial volume, V1, and the final volume, V2. And if we look at important information, test number 3, Boyle's law, P1 times V1 equals P2 times V2, and I have what those are: initial pressure, initial volume, final volume. And now I have P1 equals V1 equals P2 equals V2. By the way, how do you know to use Boyle's law? You've got a gas, pressure tells you that, and all that you're dealing with is pressure and volume, which tells you Boyle's law. P1 times V1 equals P2 times V2. We want to solve for P2 right here. How do we get it alone? Well, if it's multiplied times V2, you can divide by V2. Anything divided by itself is number 1. 1 times P2 would be P2. Whatever you do to one side, you have to do to the other. And here, I divide V2 by V2 is 1. So you got P2 on this side. This side is P1, V1 divided by V2. I like to write it. I have the word or, and then put in the numbers from what you figured out here when you looked at the problem. And then notice liters divided by liters cancels out. We're left in torr, which is a pressure, 3, 3. And this one is 5.133. That's a bracket, even though it looks like a 1. Sorry about that. 4. So the lowest significant figure, oh, wait, 4, 4, 3. The lowest is 3, which is why that's 3. All right, now, this is a good one. If you burp 86.75 grams of CO2, boy, that's going to be a monster burp. But anyways, CO2, carbon dioxide at 545 millimeters of mercury and 34.6 degrees C, then what is the volume of your burp? Now, this will be 15 points. Oh, I gave it away. And what are you being asked to find? Volume. You're given a weight of the carbon dioxide, a pressure, a temperature. Notice nothing changes here. As soon as you see that, that tells you you need to use the ideal gas law, PV equal nRT. And if you look at important information, test number 3, in the past, students have to memorize this, but now I'm going to give it to you, PV equal nRT. And notice this is very important. P is pressure in atmospheres. V is volume, it has to be in liters. N is the number of moles. T, temperature in Kelvin. R is the universal gas law constant. And for my class, I use 0.0821 atmospheres, liters, mole K. This is a calculated value. This is 3 significant figures. You can find on the internet, please don't use it, this up to 10, 15 significant figures. No, use this one. So now we know PV equal nRT, what are the different units? And if we go back and look, oh no, first of all, PV equal nRT, we want to solve for volume V. I have to get rid of P. So I divide both this by P. Anything divided by itself is number 1. 1 times V is V. But whatever I do to one side, I have to do the other. I did. And it's now this. Now, let's go through. Pressure right here has to be in atmospheres. So like we did earlier today, just a little while ago, want to go from millimeters of mercury to atmospheres. Test number 3. Important information. Notice 760 millimeters of mercury. mmHg is millimeters of mercury equal 1 atmosphere. I even put that in there in case you forgot. Boy, I'm being too nice. And therefore, here's what we're starting. Here's what we're trying to get to. Use your good buddy, your good friend. Unit analysis, atmospheres go on top, millimeters go underneath. This is 1, 760, 3 significant figures, exact number, 3 significant figures. Now, this is one of those multi-step calculations where you can round off at the end or wait or do it each step. I'm an each step person, but I will calculate it both ways because they're not always the same answer. And if you get either one, I will give you full credit. Now, next, temperature has to be in Kelvin. Oh, no, it's in degrees C. I'll be honest, I've never, ever seen a temperature device, a thermometer or digital thermometer that measures in Kelvin. Fahrenheit or Celsius, centigrade. Celsius. Centigrade's the old name. I say that once in a while. So I want to go to Kelvin. Well, how do we do that? You look at important information. Test number 3, Kelvin equals degrees C plus 273. Am I nice, right? Am I nice? So degrees C is 34.6. Add 273. Remember, 273 is an exact number. When you add, you get the same number of significant figures to the right of the decimal number that has the fewest. And the only number you're really dealing with is 0.6, because 273 is an exact number, and you get 307.6. And finally, N. What is N? Well, in case you forgot, you go back to important information, test number 3. N is the number of moles. And that's what we did earlier today, and that's why I went through it. You have so many grams of carbon dioxide, 86.75. You want to get to moles of carbon dioxide, CO2, using unit analysis, the ratio you'd use, moles CO2 goes on top, grams of CO2 goes underneath. Where do you get these numbers? Surprise, not really. Test number 3, important information. 1 mole of a compound equals the molecular weight of that compound. And the molecular weight of the compound is the sum of all atomic weights. So the atomic weight of, there's 1 carbon, 2 oxygens in carbon dioxide. Atomic weight of carbon to 3 significant figures is 12.0. For oxygen is 16.0. Do the math. By the way, 1 and 2 are exact numbers. And you add it up and you get 44.0. And this is 4 significant figures. 1 is an exact number. 44.0 is 3. You get 3 significant figures. Now, remember, I'm trying to find volume. I have N, R, T divided by P. N I'll put in from right here. R is the universal gas law constant. And in case you forgot, if you look at important information, I give it to you. Am I nice or am I nice? Don't answer that. And temperature and pressure. And you notice moles divided by moles cancel out, Kelvin, Kelvin. Atmospheres, you're left with liters. And you get this phenomenal number, 3 significant figures, which means if you think about it, 69 to 75.4 liters, your lungs aren't that big. That would be like 35 2-liter bottles you fill up with a burp that big. Boy, that would be in the Guinness Book of World Records for sure. And notice I have here both ways. If you round off at the end or at each step, guess what? You get the same answer. All right, what I'd like to do now, let's take a 5-minute break, come back. I'll do 1 or 2 more problems dealing with solutions, and then we'll do our lab for today, and I'll get you out well before midnight. Let's take a 5-minute break, come back at, it's already 9:46, come back at 9:51. I'm going to get up and stretch. See you in 5. Time to get going. It's my train whistle. Sounds good, doesn't it? All right, let's get going. What I'd like to do next is go through a problem or two from the solutions problem set. What I just did before, what I'll do now, I highly recommend before Friday, today's Tuesday, so you got plenty of time, that you try these on your own. Hint, hint, wink, wink, say no more. Do you get the message? Remember, it makes me feel good to see students succeed, not do bad on a test. So don't you want to make Dr. White feel good? Some Jewish guilt on you. All right, let's continue. All right. Now, this is from important practice problems, chapter 5, part 2. We already went through this, but I'd like to go through 2 more calculations. Thumbs up, people. Can you see this on your screen? Oh, no, you can't. Or can you? Thank you, Spencer. All right. Let me remind you, what does 1.34 capital M mean? Capital M means molarity. And I don't, and I'll open it up now. And if you look at test number 3, molarity, and I think I changed on the actual test important information, which you can, I have a capital MF in brackets after molarity. That's moles of solute per 1,000 milliliters of solution. So if we look at this, what does 1.34 capital M mean? HCl, 1.34 moles of HCl, hydrochloric acid, per 1,000 milliliters. Now, if we look at number 7, what does 4.56 times 10 to the third capital M NaCl bracket AQ close bracket means? And what is the solvent? Well, capital M means molarity, and you have 4.56 times 10 to the third moles of NaCl per 1,000 milliliters. What's the solvent? AQ, aqueous, means solvent is water. Now, let's look at number 8. How many moles of sodium chloride are in 125 milliliters of a 3.45 molar NaCl solution? What are you being asked to find? How many moles of NaCl? What are you given? 125 milliliters. And this number 3.45 with that capital M and NaCl, what does that mean? Well, you should know that's molarity, capital M molarity. That means 3.45 moles of NaCl per 1,000 milliliters. So we're starting, the only number we really have to work that helps is 125 milliliters. We want to get the moles of sodium chloride. Whatever we're trying to get to goes on top of this ratio. Whatever we're trying to get rid of goes underneath. Milliliters divided by milliliters cancels out. 125, 3 significant figures. He's in his rut again. 3.45, 3 significant figures. The 1,000 is part of the definition. Therefore, that's an exact number. Again, the 1,000 is an exact number. So you have 3, 3, exact number. Our answer has 3 significant figures. Now, let's look at number 11. How many grams of sodium chloride are needed to make 345 milliliters of a 6.789 capital M NaCl solution? What are you being asked to find? Grams of NaCl. What are you given? How many milliliters? And you're given this number, 6.789 capital M NaCl. Well, as soon as you see capital M for this type of problem on test 3, you should think of molarity. And molarity is 6.789 moles of sodium chloride per 1,000 milliliters. Now, there's no way you can go directly from milliliters to grams. So what does that mean? Well, let's look at important information. Molarity two-step problems. First, you go from milliliters to moles. And now, second step, you go moles to grams. Again, first step, milliliters to moles. Second step, moles to grams. In the past, you'd have to memorize this, but no more, because I'm going to give it to you on test number 3. And the important information will be, I think, the last 2 pages of your test number 3 PDF file. So now that we have that information, wrong thing, I can go back, step 1. We want to go from milliliters to moles. I have these many milliliters. I want to get the moles of NaCl. I'll use unit analysis. The moles NaCl go on top of a ratio. The milliliters go underneath. Where do I get a relationship? Moles of NaCl per milliliters from the molarity written this way. Put those numbers in, 6.789 moles NaCl per 1,000 milliliters. Milliliters divided by milliliters cancel out. I'm left with moles of NaCl, which is what I want to get to. 3 significant, 4 significant. Remember, the 1,000 is an exact number. Which is the lowest number? Hard question. Hopefully I'll pick 3. So your answer is 3. Now, this is one of those 2-step calculations. You can round off at the end or at each step. I'm an each step person, but I'm not going to force you to do it my way. So on the test, I will calculate it both ways. Either one, if they're different, will be the same. So I now have 2.34 moles of NaCl, but I'm trying to get the grams of NaCl. So in step 2, we have to go to moles to grams. Now, do you know why I did that earlier today and had you practice it? Because you'll need it, test 3. So I have moles of NaCl. I want to go to grams of sodium chloride. Grams of sodium chloride go on top, moles go underneath. Where do I get a relationship between 1 mole of a compound and the number of grams? Well, in case you forgot, important information, test number 3 says 1 mole of a compound equals the molecular weight of that compound in grams. And therefore, the molecular weight is the sum of all atomic weights in that compound. And being the cruel person I am, I didn't give it to you. The molecular weight, you've got to figure it out on your own. So, sodium chloride, 1 sodium. The 3 significant figures, sodium is 23.0. 1 chlorine, the 3 significant figures, the atomic weight is 35.5. Notice they both have 1 past the decimal, so you don't have to round off, and you get 58.5. So 1 mole equals 58.5, and therefore 3 significant 3, the 1 is the exact number. I get 3 significant figures, and notice on the problem set here I have, if you round off each step, or if you round off at the end, you get the same number both ways. What I just did, go back and watch the video that I'll post on YouTube later today, and try some more of those on your own. Remember the first day of class, I said, watching me do it, always look too hard until you try it on your own. It's like riding a bicycle. If you watch the Blu-ray, How to Ride a Bicycle, it's not that hard. But the first time you get on a bicycle, you'll fall off. I did. That was a long time ago, but I did. And my parents got training wheels. Then I finally learned how to ride a bike. I was about 5 then. And you don't want to fall off and go boop on the test. Please don't. All right. Any questions about anything I just went through? Remember, in my class, there's no such thing as a dumb question. Also, remember tomorrow afternoon and also, or tomorrow evening or afternoon, 5 p.m., I'll have my office hour. If you need any quick questions today, I'll stick after lab. All right, it's lab time. You guys all ready for today's lab? I hope you are. But first, I better open up something. Give me a second. Actually, it'd be more than a second. All right, what I was just doing was logging in to be on Lab Z. Let me close a few things. All right, we're ready to go. Now, earlier today, I talked about titrations. And titrations allows you to determine the molarity of an unknown solution. Let's just say you're trying to make up a solution of sodium hydroxide. So you weigh out a certain amount of sodium hydroxide in water, use a volumetric flask, and you use the calculation like I did to find out the grams of sodium hydroxide you have to add to water to make that molarity. How do you know you did it right? What if you didn't weigh it right or other errors? Well, you do what's called the standardization. And in the chemical industry and chemical labs, the most important standardized molar solution is sodium hydroxide. And there's a way of standardizing it, and that's to react it with a known acid. Now, if you had a liquid, how do you know the acid you're using, that molarity was correct? You don't. But if someone came up with a certain chemical that's a solid at room temperature, that's an acid that has one proton it can give up. And because it's a solid, you can weigh it out accurately and know that's what it is. And that solid is called KHP. And today's lab, ta-da, is standardization of a NaOH solution with KHP. Now, if you make a specific molar solution, by the way, let me just check. Everybody see standardization of NaOH solution with KHP on your screen? Thank you, Amber. And thank you for the heart, Spencer. And it's not even St. Valentine's Day. Oh, look out, he's in rare form, awful humor. But anyways, if you make a specific molar solution of NaOH, how do you know accurately, and that's the important part, what the actual molarity of that solution is? You do a titration of that solution with a standard monoprotic, that's fancy for one proton acid of known number of moles. And the universally used standard monoprotic acid for this is KHP, and the actual name is potassium hydrogen phthalate, but everybody calls it KHP. Now, KHP is a solid at room temperature. Now, important thing I don't have here, but I should mention, KHP can absorb some water. And if you think you have 5 grams of KHP, but some of that is water, guess what? Your numbers are going to be all wrong. So what you always do with KHP before you're going to use it, you put it in the oven and heat it overnight, or at least a couple hours. Then you take it out and put it in what's called a desiccator. A desiccator, and time out for time to go to the internet. Does everybody see on the left part of your screen right here, glass, it's called the bell jar with a little white at the bottom right here? You see that on your screen right now? You don't? All right, let's try again. All right, now do you see where it says desiccator on your screen? Anyone? Hello out there? Thank you. I assume you see it. Thank you, Amber. And this, in the bottom here, they don't show it here, you put a chemical that absorbs moisture. And it's got a fit. The most common one is called Chloride. Very, thank you, Ruben. Very common chemical that absorbs water. And when it's dry, right, it's a white color. When it's absorbed all the water it can, it goes to a blue or almost a purple color. And you know to replace it or put it in the oven, dry it out. And once your KHP comes from the oven, you put it in the desiccator with Chloride in there to let it cool off, but it stays dry because you can't weigh a hot sample. That will throw your balance off. So let's go back to the lab. Now, KHP reacts with sodium hydroxide in the following neutralization. Sodium hydroxide reacts with 1 mole of KHP to make a salt plus water. At neutralization, when a pH indicator, in this case we'll use phenolphthalein, changes color, the following is true. Moles of KHP equals moles of NaOH. Now, the moles of KHP equals weight of KHP times 1 mole of KHP divided by the molecular weight of KHP. If you look at equation 2, oh no, I was too nice. I didn't make you look up the weight of KHP, so I gave it to you. So moles of KHP is grams divided by 204. Now remember, moles of KHP equals milliliters of NaOH times moles per 1,000 milliliters. That will give you moles of NaOH, which when you solve for this equation, NaOH moles, you get equation 3. So in this lab, you're going to weigh out some KHP and titrate it with an unknown amount, a molarity sample of NaOH, and you stop titrating when the color changes. You can also find it on the pH meter, but I like color change myself personally. And let's look at the procedure. First of all, log into Beyond Lab Z. Then, and let's go to Beyond Lab Z. I'll go through these steps in actual Beyond Lab Z. All right, let me ask everybody, see Beyond Lab Z on your screen. Thank you. All right, now in the lower right, you see where it says titrations, and click on chemistry, or it's usually set. And now this is opening up the titrations lab. any day now. I wonder if they're having, all right. Everybody see the titration lab where you see a yellow balance on the left and a burette in the center? Thank you, Spencer. All right, now the first thing you're going to do is click on presets right here. And you're going to scroll down, see where it says sodium hydroxide standardization. You'll click on that. And immediately it gives you this. Now, if you look over at the balance here, it has 1.24 grams of 2450 if it bounces down. And I like to put a little more. This is the KHP. Click on the bottom. Hold this overneath. Sometimes it takes a little. And now you'll record this number, 2.2891 grams. That's the weight of the KHP. Now, the little X in the corner here, you'll click on. And now you'll take this and you'll put it into the speaker. All right, next. At the bottom, you'll need a beaker. Click on that. Notice the special sound effects. Take a beaker out. If we're in the lab, I'd say close the drawer because it hurts if you or I walk into it. Now, over here, you have a sodium hydroxide solution, NaOH. Pick it up and pour it in the beaker. So it's about half full. Now, here's your burette. Take the beaker and you filled it up. If you look over on the right side, the picture in the window, the bottom of this little U of, it's called the meniscus, is at 0.00. This is a burette. It's like a graduated cylinder, but you control how much liquid, in this case, sodium hydroxide, I will add to the speaker. Now, it also has a pH meter. If you want, you can scroll down here and look at this graph while you're doing it. Now, this is a burette. This is called a stopcock. It adjusts how much you're adding. Now, Dr. White's done so many of these with this burettes, and I've also used electronic burettes where you have a push button and you can be accurate to 1,000th of a milliliter. Yeah, that accurate. One company I worked at where I was hired to fix their quality control lab, I saw they were using these types of burettes. I went to the president of the company and said, guess what? To make things better, we need electronic burettes. How much are they? This was a while ago. I think they are about 7,500, 8,000 a piece. And I said, we need at least 4. So you want to spend $34,000? I'll say, let's buy one and you look at the results. And we wound up buying those and some other equipment I suggested. Now, just about all of you have never used a burette. Take your cursor, and if you go like this, when you move it like that, see how it's going in. I'm going to all right, I had this bug the other way. Let me reset the lab. If this happens to you, just reset. For the time being, I'm just going to use the amount here, but when we do it, use another, put some more on there, but we'll use this. I'll put that in there. Let's fill it up again. Let's see if it'll work now. And it's working. I've got to contact Beyond Lab Z. Obviously, they have a bug, and you saw what I had to do, reset. Now, what you're going to be looking for in the preset, we put the KHP in the beaker. In here, we have our unknown sodium hydroxide, and we're going to add until you see the color change. And you want just the first amount. Now, if we look at the graph down here, this will help. This is called shotgunning it in. I'm going to add it until I see it start going up a little. Now you can practice where I'm doing a drop or a little more or real fast. And when you see that graph start going up, like now, notice I've slowed it real down. When you're doing a titration, it's very important to be patient. And notice over here, you can see it's starting to rise, which is why I'm going super slow. You can see it moving. The burette. And this is called being near what we call the end point. The end point is when you've neutralized all the acid with the base, and it's going to change color any second now. And now I'm going to stop it. Stop. And notice how this zoomed up. Now, the initial volume was 0.00. This is, each one of these lines is 2/10. The larger line is 1 milliliter. So that would be 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And that would be 21.7. It's right on line 0. So that's your final volume. The initial one was 0.00. They have it set up for that. And you're done with this. Now, what I'd highly recommend is try this without recording any data, just to get practice using the burette. Now, you can add more base to it. Watch what happens. This you don't want to do. It's called overshooting your endpoint. See how the color in real life will get a little darker. So you want to add just enough till you get to the first change in color. And there you can see when this first starts going up, the blue line, which is pH. Conductivity, I've never worked with. I don't use it. But anyways, when it first starts going, slow down and watch for the color change. Now, notice in the lower right center, it says clear lab. You're going to be doing this twice. Whenever in a lab you do a standardization, you never do one. And my video's lagging. Is it still lagging? Could be yours too. All right, let me ask, thumbs up, people. All right, thank you, Spencer. It could be your, I don't know, maybe it's a sunspot today inspecting everybody's internet. Anyways, down at the bottom, and in case you missed anything, the video of this, you can go back and watch. Aren't you glad I provide videos for you? You'll hit Clear Lab, and again, you'll go to Preset, scroll down, find sodium hydroxide, and then repeat what you just saw me do. Now, I would do it 3 times for you. First time, just practice it, and the second 2 for recording for data. All right, thumbs up, people. Do you see the procedure on your screen? Thank you, Ruben. And this is just what I just showed you how to do. And notice step 16, repeat 3 through 7, 15 steps. And the first run, titration number 1, you'll put the grams of KHP. You'll have to calculate using equation 2, the moles of KHP, that's your acid. You'll put in the initial volume A, which in our case was 0.00. The final volume, I think, what was that, 21.7? And then the volume of NaOH was B minus A. Oh gosh, I'm making it too easy for you people. Well, that's a good thing. You're here to learn, not for me to make your life difficult. I didn't say that, oops. But anyways, and then the molarity of the NaOH, you'll use equation 3 up here. You have moles of KHP times 1,000 divided by the milliliters used, which you calculated right here. And that's today's lab, plus these questions. So that's today's lab. It's a lot of fun playing with that burette, even though they do have a bug that I'm going to have to run them through talking to you today. I'll know some people at Beyond Lab Z. I'm going to email them, let them know there's a problem. So with that, I'm done. I'll stick around for a little while if anybody has any questions. I hope those who are having internet problems, that clears up. And with that, I'm going to say, gang gesund, goodbye. I'll see you tomorrow. Don't forget, tomorrow I'll do my world famous review for next test, test number 3. And I'll say it again, gang gesund, be healthy. Bye.